So welcome everybody to this latest video on 162 Maths, and in this video we're going over the AQA AS Maths paper of May 2020, paper 1 section A. Now as always I'll include a question breakdown in the description below so you can see which topic each question refers to. So let's get straight into this May 2020 AS Maths paper 1. So looking at question 1, it says at the point 1, 0 on the curve of ln x or ln x, which statement below is correct? Now to help with this question, it makes it easier if we start by doing a little sketch of what ln x looks like. So if I do my reflection line of y equals x, then ln x or ln x is going to look something like this, where 1, 0 is at that point there. Now at this point, the gradient is going to be positive, but it is going to be decreasing because the gradient is going to get smaller and smaller and smaller. So the box that needs to tick is going to be the third option. Then moving on to question 2, it says given that f of x equals 10 when x equals 4, which statement must be correct? Tick one box. And the correct answer there is going to be this one here. Now the reason for this is because when you are technically multiplying something by 2, you are going to be dividing it by 2. So therefore here we're halving x, so therefore we're going to be doubling our x in our function because it always has the opposite function when it comes to graph transformations. Then moving on to question 3, it says Gia has to solve the equation of 2 minus 2 sine squared theta equals cos theta, where theta is between an inclusive of minus 180 and 180. And it gives us Gia's working out as follows. And it says Gia's teacher tells her that her solution is incomplete. Explain 2 errors that Gia's made. So her 2 errors, if you've not been able to spot them, well, the first one is at this stage going into this stage. And the reason for that is because at this stage, what she has done is she has divided both sides by cos theta. Now, typically, that would be fine. However, between the region of when theta is between minus 180 and 180, cos theta can equal 0. So one of the first errors is that you can't divide by cos theta, as cos theta can equal 0 when theta is between plus and minus 180 degrees. So that's the first error. The second error is that we should have 2 solutions. So cos theta equals 0.5 has 2 solutions when theta is between positive and negative 180. So that will be her 2 mistakes. Then for question 3b, it says write down all the values of theta that satisfy the equation, and we've got our equation here. So if we pick it up where she was correct, which was at 2 cos squared theta, and it was minus cos theta equals 0, and make it equal 0. So here we factorize with respect to cos theta. So cos theta equals 2 cos theta minus 1 equals 0. So either cos theta equals 0, in which our 2 solutions are going to be plus or minus 90 degrees, or we've got cos theta equals a half, in which theta is going to equal plus or minus 60 degrees. So our 4 sets of solutions is going to be plus or minus 60 and plus minus 90. Then moving on to question 4, it says in the binomial expansion of root 3 plus root 2 to the power of 4, there are 2 irrational terms. Find the difference between these 2 terms. So first things first, let's work out what the terms are going to be. So for the first one, now again, how you expand the binomial expansion might be different. You might use the formula, you might develop it your own way, but regardless of that, I'm going to do the way that tends to make more sense for me, and that's probably the quickest. So if I write down Pascal's term, the first term, and then the second term, Now the second term starts with the power as the lowest and the first term starts at the highest. So that's going to be my first term. The second term, so again 4, 1, and I've got root 3 squared to the power of 3 times root 2 to the power of 1. Then the third term is going to be 4, 2, and root 3 squared times root 2 squared. Fourth term is 4, 3, and then the final term is going to be 4, 4 times root 3 to the power of, well, that should be 1, and that should be 0, and I realise I've changed the colour of my pen, and here we go, times root 2 to the 0. Now looking at these, which of these are going to give me an irrational number? Well, this one isn't, because when I raise a root to an even power, it's going to give me a nice answer, so that's going to be a rational number. The second one is irrational, third one is rational, fourth one is irrational. So the two answers I then want to work out are these two here. So if I type that straight into my calculator, for this one I'm going to get 12 root 6, and for this one I'm going to get 8 root 6. Now the question's asked for the difference between the two, so the difference is going to be 12 root 6 minus 8 root 6, which is 4 root 6, and there is my final answer. Then moving on to question 5, it says differentiate from first principles y equals 4x squared plus x. So first things first, let's write down the original function. So I've got 4x squared plus x. Then I'm going to write f of x plus h. So that's going to be 4 lots of x plus h squared plus x plus h. And then from this, what I then want to do is substitute it into the formula. So I've got the limits of where h tends to 0, and that's going to equal, so again using the formula for the gradient of between 2 points, it's going to be 4x plus h squared plus x plus h minus the x ordinate of the previous one, so that's going to be 4x squared plus x, all over the x ordinate, which is going to cancel out, in which I'm going to end up with is x plus h minus x. So if I do a bit of simplifying, then what I end up with is 4x squared plus 2xh plus, and it's going to be h squared plus x plus h. So all I've done is just expanded that first bracket. Then if I expand this next one, actually I'll leave it in a bracket to start with, and that's all going to be over h. Then continuing the simplifying, I get 4x squared plus 8xh plus 4h squared plus x plus h minus 4x squared minus x, and that's all over h again. Then from here, what I can do is just simplify that top, in which that's disappeared. So here, just simplifying, the 4x squared cancels with this, the x cancels with that. So all that I'm left with is 8xh. Now remember, that's not 8 times h, that's x. 8xh plus 4h squared plus h all over h. Then from this, I can then cancel the h's out. So all that I'm left with is 8x plus 4h plus 1. And then as h tends to 0, then all I'm going to be left with is going to be 8x plus 1, and there is my final answer. Then moving on to question 6a, it says it is given that f of x equals x cubed minus x squared plus x minus 6. Use the factor theorem to show that x minus 2 is a factor. So if x minus 2 is a factor, then f of 2 equals 0. So then substituting f of 2, I get 2 cubed minus 2 squared plus 2 minus 6, and that does equal 0. So therefore x minus 2 is a factor. Now it's really important that you do state this line, because they are now coming down hard on the marking of this to make sure that you are kind of stating what you've actually gone on to prove. And sometimes it's always good practice to also state what you're going to use to either prove or disprove what they've actually asked you to prove. Then moving on to question 6b, it says find the quadratic factor of f of x. So for this, if I come back to this, so we know that we've got x minus 2, and it's going to be something ax plus bx plus c, and that equals x cubed plus x minus 6. Now whichever way you want to do it in terms of comparing coefficients, but basically this all here is going to add up to x squared plus x plus 3. So that there is the quadratic factor. It then says for 6c, hence show that there is only one real solution to f of x equals 0. So if only one solution in x minus 2 x squared plus x plus 3, then x squared plus x plus 3 equals 0 has no solutions. So what we need to then do is use discriminants to show that. So we've got b squared minus 4ac. So then from this we get a equals 1, b equals 1, and c equals 3. So then substituting, we get 1 squared minus 4 times 1 times 3. And we can see here that this is going to equal a number that's less than 0. So therefore there is only one solution. Then moving on to question 60, it says find the exact values of x that solves, and we've got this expression here. Well, if we let y equals e to the x, then what this then becomes is y cubed minus y squared plus y minus 6 equals 0. Now this is exactly the same as what we've been dealing with in parts A, B and C. So this therefore can be written as y minus 2, and then it's y squared plus y plus 3 equals 0. Now here we only know that there's only, so the only solution is when y equals 2. So therefore e to the x equals 2. And then if I then take the ln of both sides, so I get ln e of x equals ln of 2. I end up with x equals ln 2, and there is my exact value of x. Moving on to question 7, it says that the curve C has the equation of y equals x squared. C is translated by the vector of 3, 0 to give C1. The line L has the equation of y equals x. L is stretched by a scale factor of 2 parallel to the x-axis to give L1. Find the exact distance between the two intersection points of C1 and L1. So first of all, let's deal with C1. Now we know that from C1 that what I've got to do is use a graph transformation where I'm shifting this 3 squares to the right. So then from this, what we then get is C1 is going to be equal. Now to do a shift of 3 places to the right, I take away 3 from x. So the function then is going to be x minus 3 squared, and that's going to equal y. Then what I then need to do, and I'll just highlight that, so that's my C1, and it's going to be y equals x minus 3 squared. Then for L1, I know I've put a little dot there, so L1, what we've got is we've got y equals, now for it to be a stretched scale factor of 2 parallel to the x-axis, what I have to do then is become y equals a half x. So then I've got my two equations. So this is L1 and that is C1. So to find the intersection point, I make those two equations equal to each other. So I've got x minus 3 squared equals a half x. Now from this, if I expand the brackets, I get x squared minus 6x plus 9 equals a half x. And then if I take it all onto one side, I end up with x squared minus 7 over 2. And it's not going to be 7 over 2. It's going to be 6.5 will be 13 over 2 over 2x plus 9 equals 0. Now from this I can then just find the values of x. So I can solve, and I'll probably use my calculator, using the calculator in which I get x equals 2 or 4.5. Now when x equals 2, I substitute that into probably the most easiest one, which is y equals a half. So then using y equals a half x, I get y equals 1. So my coordinate then is going to be 2, 1. Then when x equals 4.5, y is going to equal half of that, which is 2.25. So my second coordinate therefore is going to be 4.5 and 2.25. Then I've got to go back to remember that the question is asking me to find the exact distance between those 2 points. So then using 2, 1 and 4.5 and 2.25 to work out the distance, it's going to be square root of x2 minus x1. So it's going to be 4.5 minus 2 squared plus y2 minus y1 squared. That's all square rooted. So d is going to equal, and if I type that all into my calculator, I get 5 root 5 over 4. Then moving on to question 8a, it says find the equation of the tangent of y equals e to the 4x at point A, e to the 4a. So for this I need to use differentiation. So dy over dx is going to equal 4e to the 4x. Then from this, so when x equals a, then what I get is dy over dx is going to equal 4e to the 4a. So then I've got my gradient, I've got my coordinate, so I've got m equals 4e to the 4a. I've got my coordinate of a, e to the 4a. So then the equation of the straight line is going to be y minus e1, which is e to the 4a, equals the gradient m 4e to the 4a x minus a. And I'd probably leave my answer as that. You could simplify it, but I'm just going to leave it as that. Then moving on to 8b, it says find the value of a for which the tangent passes through the origin. So at the origin, we've got 0, 0, that x equals 0 and y equals 0. Now if I substitute that into the equation, so sub into the equation, so I've got y, which is 0, minus, and it was e to the 4a, equals m, which was 4e to the 4a, and it was x, which is 0, minus a. Then if I neaten that up, I get minus e to the 4a equals 4e to the 4a and times minus a. And then if I take everything all onto one side, I get 4ae to the 4a minus e to the 4a equals 0. I can then factorize by taking e to the 4a out, in which I get 4a minus 1 equals 0. Now e to the 4a can't equal 0, so therefore 4a minus 1 equals 0. So then working with this, we get a equals a quarter, and there is my answer. So moving on to question 8c, it says, hence find the set of values for m for which the equation e to the 4x equals mx has no real solutions. Now, to get proper understanding of this question, what we need to do is we need to sketch y equals e to the 4x. So if I just do a little sketch on the side here. Now e to the 4x is going to look something like this. So this is a line y equals 4 e to the 4x, and let's just write that out there. Now to start off with, we know that any negative straight line, now this here is a straight line graph, so straight line, and it passes the origin or through the origin, so we know it's going to intercept here. Now any line with negative gradient, so in other words going downwards, is definitely going to cross that red line, is going to cross y equals e to the 4x. So therefore m has to be greater or equal to 0. Then if we find the point of intersection of this point here, which we know is when a is a quarter, so at this point a equals a quarter. Now if I substitute a equals a quarter into e equals 4x, then the coordinate I get is that this point here is going to be at a quarter. Then if I substitute a quarter into e to the 4x, I get e. So this coordinate here is a quarter e. Now for this, what I need to do is then, if I then work out the gradient of this straight line, of this pink line, imagine it was straight. So here, the gradient of this line, and picking the 2 points that I know, which is 0, 0, and a quarter e, is going to be, well, if I take the e coordinate as my second coordinate, I've got e minus 0 over a quarter minus 0. And that's going to simplify to 4e. Now, basically, for this, if I just draw another line, just deciding which colour to go for, let's go for green because that should come up. So, for there to be no solutions, the gradient needs to be between these two, the pink line and the green line. So, at this green line, m equals 0, and for the pink line, the gradient is m equals 4e. So for there to be no solutions, we're going to draw a straight line that's in between goes through the origin, but is between the pink line and the green line. So therefore, m must be between 0 and 4e. It can be inclusive of 0, but it can't be inclusive of 4e. So there is my final answer. Now looking at question 9, it says the diagram shows a circle and 4 triangles. AB is the diameter of the circle and C is the point on the circumference of the circle. Triangles ABK, BCL and CAM are equilateral. Prove that the area of triangle ABK is equal to the sum of the areas of triangle BCL and triangle CAM. So let's first of all try and label this diagram. So we know that this first triangle of AKB is an equilateral triangle. So that means that this angle here is going to be 60. And the same thing applies with each of these. So if I just start by labeling some of these angles, we get the following. Now, as AB is the diameter circle, then that means that the triangle ABC is going to be right angled. Now we know using Pythagoras' theorem that AB squared is going to equal, because that's the hypotenuse, it's going to equal AC squared plus BC squared. Then from this we know that the area of triangle ABC BK is going to be equal to a half times a common side, which I'm going to use AB. So it's going to be AB times AK, which is also AB because the sides are equal because it's an equilateral triangle, times sine 60. I can then work out what the area of triangle BCL is going to be, and that's also going to be, so BCL is this triangle here, so it's going to be a half times BC times BC times sine 60. And then moving on to the next triangle, so we've got this triangle here, that we know that the area of AMC is going to be, or CAM, let's write CAM, is going to be equal to a half times, and that line there is AC, so it's going to be AC times AC times sine 60. Now if I just start by labeling these triangles up, so what I want to show is that if I add these two things together, it's going to equal the top line. So if I've then got the area of CAM plus the area of triangle BCL, just stick a little triangle there, then what that equals is a half, and it's going to be BC squared times sine 60 plus a half, and it's AC squared sine 60. Now if I do a bit of factorising, then what I end up getting is, with these I can take a half sine 60 out, in which then I've got BC squared plus AC squared. Now using Pythagoras, I know that BC squared plus AC squared equals AB squared, and a half sine 60 times AB squared, so I've got this, and that is the same as this, so that's AB squared sine 60. So if I just create a little bit more space, and which is the same as area ABK, which is a half times AB squared times sine 60, and there we go. Then moving on to question 10, it says that Raj is investigating how the price in £P of a brilliant cut diamond ring is related to the weight C carat of a diamond. He believes that they are connected by the formula of P equals AC to the power of n, where A and n are constants. Express LNP or LUNP in the terms of LUNC or LNC. So what we've got in terms of this formula is P equals A times C to the power of n. So if I take the log of both sides, or natural log of both sides, I get LNP equals ln, and it's going to be A times C to the n. Now I can expand the left hand side, because as we're multiplying it's adding, so it comes ln A plus ln C to the n, which then gives me my formula of LNP equals ln A plus n ln C. On to 10b, it says Raj researches the price of 3 brilliant cut diamond rings on a website with the following results. And the question is asking us to plot LNP against LNC for the 3 rings on the grid below. So for this, first things first, what we need to do is we need to work out the coordinates that we then need to plot. So I need to work out what LNC is and what LNP is going to be for those 3 results. So for this, all I need to do for this first value is just type in ln of 0.6. For this one, ln of 1.15, and this one is going to be ln of 1.5. And if I do that correctly, I should have the following results. So I get minus 0.51, 0.14 and 0.405. Then for The p-values, all I've got to do is just type in ln of 495, which is 6.2. Then ln of 1200, which is 7.09. And then ln of 1720, which is 7.45. Then all that's left for me to do is then plot these coordinates. I'm plotting, oh, I don't know why I've done that, so let me get rid of that. And so I want to plot this point against this point against this point, and this point against that point. Then we're going to use green because it will just wipe it out. So going back to our set of axes, we're looking at minus 0.51, which is about there, and 6.2, which is roughly, I would say, about there. My next point is at 0.14, so that's going to be 2 squares in, and it's 7.1. So again, yours is going to be definitely a lot more accurate than mine. I make it out to be just about there. And then the last one is 0.405, and that's going to be at 7.45, so it's going to be roughly about there. And then all that's left for me to do is then possibly draw a straight line. It then says, explain which feature of the plot suggests that Raj's belief may be correct. Well, it's the fact that it's in a straight line. So something along those lines, because it represents a linear function, it's going to be all good. Then for 10bii, it says, using the graph on page 15, estimate the value of a and the value of n. Well, for this, ln a, going from the equation part a, is the y-intercept. And if I use my graph to work out what the y-intercept is, I get that ln a is roughly around about 6.9. So if I then go on to work out what a is, so a equals e to the 6.9, I get an a value of 992. Then to work out n, well, n is the gradient. So then if I go back to my graph, I draw a triangle, doesn't matter what size triangle it is, and I work out the gradient from that line, I get an answer that is close to around about 1.37. So as long as your answers are generally close to each of these, but you've stated about how you've collected those piece of values of a and n, then that should be absolutely fine. It then says for 10c, explain the significance of a in the context of this context. Well, in this context, a is the price of, or should I say, for a 1 carat diamond. Then moving on to question 10d, it says Raj wants to buy a ring with a brilliant cut diamond that weighs 2 carats. Estimate the price of such a ring. So for this, all you need to do is just enter those values. So p equals, and just going back to that formula, it was equals to a c to the power of n. So it's going to be 992 times 2 to the power of 1.37. And if I type that all into my calculator, I get an answer of 2560. And that concludes section 8 of this paper.